Okay. I can't move that, can I? Oh, that sucks. I can't move that? Oh, no. Yeah. That's not cool. Okay. So, what we have here, we are trying to prove that triangle DAB is congruent to triangle BCD. There we go. Oh, here he is. I didn't mean to do that. So if I highlight or kind of move over it, I'm trying to prove that those. So I would make sure you highlight on that unjustified so you can see what they are trying to prove here. Now, what did they give us over here? They gave us that ABCD is a rectangle, and they told us that BD is a diagonal of rectangle ABCD. All right, so then now what we want to do, let's just see here. Angle BD, oh, line BD, I'm sorry. So line BD, what we can do with this one here, let's go to add a new claim. Now, is line BD, is that shared by both of those like small little triangles in there? Yeah, BD is shared. Both of them have that same exact line. So now, how we use transitive to say that two angles are connected to a third angle, a little bit like that is this next one we're going to use with the angles here. Now we're going to say that these are going to be congruent segments. So make sure you go to add a new claim, go to the line, and we're going to go, they're congruent. Now which ones? We're going to say BD is congruent to BD. Because if we were to split those two triangles apart, that same exact line would be consistent on both triangles. That's my statement. Now my reason for that, did it just cut off on me? What happened? Oh, there you go. Now, if you look through here, search those options and read which one makes sense. What does it say? What's the first one say? What was it called? Reflexive, right? Look at that. So that's why you want to read them before you click on them. We go to the first one, reflexive. A segment is congruent to itself. So yeah, that's what we have for this problem here. BD is congruent to BD. They're the same. Submit. So now we have that line. Now look at the hash mark, right? It's a little one line saying that particular line is congruent to itself. As you're proving more and more angles and lines, you'll have more arcs and hash marks to signify which parts are congruent amongst the different shapes. All right, so now you're saying that ABCD is a rectangle. Now, if it already tells you it's a rectangle, what do you remember about rectangles? What do you remember? Yeah. Well, yeah, I mean, a triangle is a rectangle or square split in half or diagonally, yeah, so we have that. But what else? What about the sides of a rectangle? What do you remember? Say it again. Well, you have the opposite sides are congruent on a rectangle, right? Opposite sides are congruent. So if it's already a rectangle, let's see if this is going to work. Let's go to add a new claim. And now I want to still go with congruent segments. But now I want to say that line AD is congruent to line BC. Now, since they told us it's a rectangle, this should work. And now what are we going to say? Let's look around here. Let's see what we have. Are there some options that make sense? Kind of look over them and see which ones might make sense. Let me see. I might have picked one that might not work, but we're going to see anyway. Let's see if that works. Oh, no, it's a rectangle. That's not going to work. Oh, dang it. That's not. Yeah. You know what? Let me see. Let me go up here and try this one out. Oh, I don't see it. All right, well, that's not working there then.
This is the one next to it.
This one?
I don't know. if you go back to the AB, okay, go back to the ABDC, and then it's the one next to the square.
This one?
No, it's the yeah, that's that one.
Well, it's a rectangle, not a parallelogram. Well, let's just see if they're going to give that to us. Oh, they did. Okay, that works. We'll go back. So what we did on that one, because a rectangle is a parallelogram, because it has opposite sides that are congruent. So when we went back over here, oh, I don't want to use that one. I'll set it up one more time then. So then now we can go to add a new claim. Let's do the ADs congruent to BC one more time so we can see where that came from. Now, yeah, we're kind of pulling out a different shape we haven't talked about yet, but it'll help. So let's type in there one more time. If you didn't get it, AD is congruent to BC. Now, the reason why this works is because a rectangle is also a parallelogram. So now if we go to the second row, almost kind of right in the middle here, in a parallelogram, opposite sides are congruent. And a parallelogram is also a rectangle. A rectangle is a parallelogram. So if you click on that one there and you put in that ABCD is a parallelogram, it also is a rectangle. So they mean the same thing for this shape. They don't say that those two sides are going to be congruent. But now we're going to do the same exact thing, and we're going to do the other two sides, AB and DC. So let's just do it again. So let's go to add a new claim. We're going to go to line, going to congruent segments. Now we're going to say AD is congruent to BC. Now, not all of these you're going to pull in a different shape. It just happens to work for this one. AD is congruent to BC. Yeah. You click on the line. You make a new claim, go to line. We went to first one, congruent segments, saying that those two sides are congruent. You type in AD is congruent to BC. Those are the lines we're talking about. Go to claim. Now that's our statement. Our reason why that works, if we go to confirm, it's that same middle one that Ian was talking about here. In a parallelogram, opposite sides are congruent because rectangles are also parallelograms. So now click on that one there, and now they gave us the name of it, A, B, C, and D, to say that now those two sides are going to be congruent. And we submit it. Now, we have all three sides that are oh, I clicked the same ones, didn't I? Oh, dang it. Why did somebody say something? Dang it. My fault. It should be A, B, and DC. I wrote the same one twice. A, B, and DC. There we go. Now, if you look at your shape, right, you realize the middle line, the purple one, has one hash mark. Those two lines are congruent. Now we have the yellow one. They have two hash marks. Those two lines are congruent. Then you go the top part of your rectangle, the teal one. They have three lines. They're giving you by shape and hash mark which ones are going to be congruent. That comes into play now because now for the last one, we have all three sides that are congruent on each triangle. Right? So now we're going to go, let's click on the unjustified claim. Now, which one of those options makes sense? The second one, right? Side, side, side. But this is where you got to pay attention. Now, remember now, for the angles, if you named it incorrectly, it wouldn't work. It's the same thing for your triangles, right? Your sides have to be lined up exactly. Let's go with the one that has one hash mark first. What is that line called?
So you could just click the things on the justified.
I could, but I don't want to do that. I want to actually make sure we type it in correctly. So the one with the one hash mark, what is that line called? Say it again. BD. So BD is congruent to BD. Now let's go second hash mark. Now remember now, the one on the left, you got to pay attention to this up here. We have to do this right, because if not, it won't work. At the very top left, now some of you did it a different way, but sometimes it might not work out that well. Top left, right, this triangle says DAB. This is the left side triangle. Everything on this side must be the left side triangle, DAB. Everything on the right side must be the BCD triangle. If you confuse either one, it won't work. you feel you have it wrong, but you really don't. You put it incorrectly. Left-hand side is all triangle DAB segments. BCD is all right-hand side. I got to finish this problem because it's now 9:30. If you already have the problem, you can start packing things up, those that don't. So that's DAB. So I'm going BD, now triangle DAB. I'm going to go, so please be quiet as you do it though. DA is congruent to BC. The one with 3 hash marks, I'm going to go AB is congruent to DC. And then there we go. We have it proved by side, side, side.